Good morning. So in this one, we are going to discuss the properties of good sand from the exam point of view. Standard question. Okay, properties of good sand. What do you mean by good sand? See, so whenever you are using for a construction purpose, maybe plastering, maybe masonry, maybe concrete, maybe filling, whatever may be the case. So if you want to use, then what the properties it should possess? What are the properties such that sand should possess? So that is why we call it as good sand. Then what are the properties? Okay, it should be chemically inert, means what? It should not react with other materials. Chemically inert is one thing which is very active, so which will react. The word inert, opposite to that, inert means very active. Chemically, what is that? Inert means very active and it will react with this thing. Opposite to that is chemically inactive, it is not going to react. Okay, it should be chemically inert, means it should not react, it should not react. Okay, chemically inert. It should be clean, it should be coarse, it should be free from organic matter. Usually a percentage permitted organic matter is 3 to 4%. If 100 kg of sand you are taking, 100 kg of sand is taking, 3% of organic matter if it is there, then it is a no problem. Okay, 3%, 3 to 4%. It should contain sharp, angular, coarse, durable grain. Okay, this is one. Sharp and angular is depends upon the usage. For plastering work, the particles should be smooth and rounded. One thing I'm just telling, in the detail you are going to understand later. Okay, sharp and angular particles. If a particular particle is, if a particular particle is very sharp, I'm just telling what is the advantage. If a particle is very smooth, what is the advantage? In both cases we will discuss. Sharp means bonding is good, bonding is good, but workability means how easily you are going to mix and place is going to be difficult. Workability will be difficult. Here bonding will be less, particle to particle, but workability is more, means what? You can mix, place, compact the concrete very easily. Okay, so properties also depend upon the final usage. For some work you require sharp and angular, for some work you require smooth and rounded. Okay, but in general you can say it should contain sharp and angular, coarse and durable. Durable means again particles should not break under the action of forces. So three parts. It should be chemically inert, means it should not react with other things. Organic matter should not be there. Maximum limit is 3 to 4%. And the sharp and angular, coarse and durable grains should be present. These are the first 3 points. What are the other good things? It should not contain salts. We have seen no efflorescence, dampness problem will there. It should not contain salts which attract moisture from the atmosphere. First thing. Second thing, it should be well graded. I will explain this term, well graded. That means it should contain particles of various sizes in suitable proportion. Particles of various sizes in suitable proportion. Suppose if you take 1 kg of any sample, 1 kg of any sample, it should contain almost different types of sizes. So if almost all particles are of same size, same size, what will happen? It will create larger voids. Here voids will come. Voids means empty spaces will be more. Only one size. So this type is called as a poorly graded. If a sample, let us say sample contains all sizes. What do you mean by that one? Bigger particle is also there. If any void is there, to fill that one, smaller particles is also present in that sample. So continuously all sizes are present, then it is called as well graded. You understand which case voids are more? Here, poorly graded. Voids are less in well graded. Okay, Cement consumption is more here. Cement paste consumption is more because more whites are there. To fill these whites, no aggregates, so only left is cement paste. Okay, more cement paste. Okay, more cement paste means it is not economical. It is not economical. Okay, in well graded, less whites, less gaps, and cement paste consumption is also less, so it is becoming economical. It is becoming economical. Here it will be more strong. Here more whites is there. Cement paste is more. Cement paste is generally weaker than these aggregates. Okay, in wet condition, cement paste is weaker, so this is not so strong compared with this one. This is more strong. Okay, in a given concrete work, if you are using well graded sand, means what, almost all particle sizes are present, then you are going to get good concrete. Here you are not going to get good concrete. Okay, this is the difference between well graded and poorly graded. Okay, next is the fineness modulus of sand should be 2 to 3. So what do you mean by fineness modulus? There is one test, we call it as a sieve analysis test. So we are going to see, there you will understand the term fineness modulus. Okay, so is it clear? Okay, so no salts, it should be well graded, and general fineness modulus should be 2 to 3. Okay. Okay. Now, very important, functions of sand. Functions of sand in mortar. Mortar means cement is there and aggregates is there. So cement is there and aggregate. In aggregate also you have only fine aggregate. You have only fine aggregate. Fine aggregate is nothing but sand. If only these two are there, then we call it as mortar. Cement and sand, only mortar. To this mixture you are adding coarse aggregate. Coarse aggregate means bigger aggregates. So these three mixture plus water, we call it as concrete. Okay, only cement, sand, water, we call it as mortar. Cement, sand, coarse aggregate plus water, we call it as concrete. We call it as concrete. Okay, so it is clear? Okay, mortar and concrete. Now, what is the function of sand? Function of sand in mortar and concrete? Bulk. Bulk means what? For a given volume, for the given quantity of aggregate, if you are using more sand, then general volume you are getting is bigger. General volume is you are getting bigger. In simple way, you understand that it acts as adulterant. Adulterant is nothing but it will bind the cement particle, or it will act as a joining material, joining thing. Okay, so bulkage you are going to get. Bulkage means more volume you are going to get by adding sand in a cement mortar. Okay, by adding cement mortar. Hence, the voids or volume of mortar is increased, which results in cost. See, for a given cement mortar quantity, more sand is added means more mortar you are going to get. So, results in what? Savings, no? You are not adding cement here, you are adding sand here. More sand means more volume, so cost is going to be less. So, bulkage means you are getting somewhat extra quantity in volume by adding sand. That's all. Bulkage, it will give bulkage to the given mortar or given concrete. By adding sand you are going to get more volume. That is the function of sand. Okay, one is bulking, bulk. Okay. Okay, so have you heard the word, oh, that person has ordered that t-shirt in bulk? Bulk means what? Large quantity of orders you have given. So that means in the same way you understand that bulk sand means more volume you are going to get. That's all. Setting, it helps in setting of mortar and concrete. Setting means hardening process. Hardening process. So water is slowly consumed by cement and it will start getting hard. So by adding sand, this setting process is favored. By adding sand, setting process is favored. So it will help in setting. Okay. Now, here shrinkage, in the beginning only you understand that for a given volume, as the time goes, if there is a reduction in volume, then we call it as shrinking or shrinkage. How much it has shrink, how much it has volume has reduced, that property we call it as shrinkage. See, for a given sample, for a given quantity, so two samples are there. This is also 10 kg. Let us say it is also 10 kg. Let us say in that way. Here sand quantity is less. Here sand quantity is more. What is happening? In both cases, the shrinkage will be there as the time goes. Shrinkage is more in this case. Shrinkage is more in this case. Shrinkage is less in this case. Why? Sand is more. So when you are adding sand in a higher quantity, overall shrinkage is reduced. Overall shrinkage is reduced. Okay, that is the advantage. So it prevents excessive shrinkage of the mortar, okay, in the course of drying. Hence cracking of mortar is avoided. So if the volume is reduced, obviously cracks is going to come. Change in volume, nothing but going to be cracked in the next phase. Okay, like that. Okay. So first function is bulk, second function is setting, third function is reduces the shrinkage. Here it provides bulkage, it helps setting, it avoids shrinkage. Next function is strength. Obviously sand plus cement you are using means it is going to get more strength. If you are using only cement, then strength is not there. Okay, strength you are not going to get. If you add sand or if you add aggregates, then only that mixture will get strength. So in that way it helps in adjustment of strength of mortar or concrete, both case, by varying the proportion with what, cement as well as lime. Okay, so in some cases you use cement, but in village side they use lime. Okay, it also increases the resistance of mortar against crushing means what, in a wet state if you apply small load also, so it is going to break or crush. So by adding somewhat sand, so the obviously strength is increased. So here what point you should understand, sand is providing strength to the mortar or concrete by varying its proportion means 1 is to 3, 1 is to 4, like that. Okay, so here 1 part of cement, 3 parts of sand. Okay, like that. In the next one, it is providing more surface area. More surface area means by adding sand, the total surface area on that particle is increased. So what is happening, more surface area means that the wall coverage, if you are doing a plaster, you can cover that plaster for larger area, so that is the point here. Surface area, here you can get more surface area or larger surface area. What is happening here, the subdivided paste of the building material into thin film, and thus more surface area is offered for its spreading and adhering. Here what is happening, more sand particles are there, and cement paste is covering on the surface. So in that case, more surface area is obtained for spreading and adhering. So what are the points here? One is bulkage, second is setting, third is shrinkage reduction, fourth is strength, fifth is more surface area. Here in this part we can see impurities in sand. What are the impurities generally we come across? Maybe clay, silt, salts, mica, organic matter. These are the main impurities. Apart from that, if you are using sea sand, you are going to get shells, no? Shells. That is also one type of impurities. So maybe wood particles is also an impurity here. Generally, there is a limit. You can use less than 5% impurities are there, then you can use. But it should not exceed 5%. It should not exceed 5%. And some for silt you can have up to 8% limit, for mica 2 to 3%, for 2 to 3%, when that sand is used for mortar and concrete. What is going to happen if the silt content is more or mica content is more? Then what is going to happen? The bonding property, strength acquiring property is going to be reduced. Shrinkage shrinkage defect is going to be increased. Strength less, bonding less, shrinkage more, cracking more. Okay, these are the problems with the impurities. Okay, this is the here. So what grading we are going to discuss? What do you mean by grading? So in the that previous only I have explained, if a given sample contains all particles, almost all sizes of particles, voids are less, then it is called as good grading. Okay, so good grading implies that sample of aggregates contain all standard fraction means all sizes: 4.75, 3.36, 1.26, 2.12. Okay, so like that all sizes are present, then it is called as good graded. So what is happening here? It is having minimum voids. It is having what? Minimum voids. Okay, the previous one only we have seen all sizes are present, less voids. What is happening? If voids are there, smaller particles will come and fix there. Smaller particles will come and fix there. So 4.75 aggregates are there. 4.75 aggregates are there. So the voids have become present here. Voids are present here. So in these voids, 1.26 aggregate will come and fix. 1.26 aggregate will come and fix. So in that way, the voids are going to be minimum. The voids are going to be minimum. Here, a sample containing minimum voids will require minimum cement paste. Okay, less voids means less cement paste to fill the voids in aggregate. To fill the voids in aggregate, what will happen? Minimum paste means less cement. Simple, no? Paste is nothing but cement plus water. Paste is nothing but cement plus water. Paste is less. Why? Voids are less. Paste is less means cement also less. Cement less means it is a costly material, no? So the cost is also going to be less. Cost is also going to be less. So what you will get? You will get economy. You will get economy, higher strength, lower shrinkage, greater durability. Okay, these are the advantages of having good graded aggregate. Good graded aggregate. So voids are less, all sizes particles are present, voids are less, so the paste is less, cement is less, cost is reduced, so hence it is economy. Apart from that, naturally strength is higher, lower shrinkage, greater durability. Okay, in the next part we are going to see sieve analysis. Okay, next part we are going to see the test on the sieve analysis.